So we're going to go back and think about limits like we did last semester, but the real reason we're talking about this now is there's a nice application for derivatives that makes computing limits a little bit easier. So let's look at this first limit here and think back to how we would have approached this last semester. So hopefully you can remember, but last semester, the first thing we would have done is we would have plugged 1 into this equation to see what happened. When I plug 1 in, natural log of 1 is 0, and 1 minus 1 is 0. So I get 0 over 0. Remember, 0 over 0 doesn't mean that this is undefined. It doesn't mean it doesn't exist. It doesn't mean the answer is 0. It means we have no idea what's going on. So what we need to do is we need to figure out what's happening here. And stop and think for a second, what did we do last semester when we got 0 over 0? Hopefully you remember that last semester what we got, or what we did at that point is we said, well, we should be able to simplify things. And sometimes that meant we factored, sometimes it meant we multiplied by the conjugate or found a common denominator. In this case, if we look at this expression, there's really nothing we can do. This looks as simple as it possibly can get. So we need another method for dealing with this. And so this is L'Hopital's rule is going to be what allows us to deal with things like this. So L'Hopital's rule looks weird, but once we start doing it, it's not going to be so strange. So L'Hopital's rule tells us if I start out with a limit where I get either infinity over infinity or 0 over 0, then what I can do is I can take the original expression and I can replace it with something. So I take the derivative of the numerator and I take the derivative of the denominator, and then I compute the limit of that new expression. Notice that we're not trying to do quotient rule here. We're not trying to take the derivative of a function. We're just replacing our original limit with a new limit, and L'Hopital's rule tells us that these two limits are equal to each other. So let's see how we use that up here. So first of all, we have 0 over 0. So this is a case in which we can use L'Hopital's rule. So L'Hopital's rule tells me, I'm going to write LHOP here just to remind myself I use L'Hopital's rule. Tells me I take the derivative of the numerator, 1 over x. I take the derivative of the denominator, 1. And I just leave this. Notice we didn't do quotient rule here. We didn't do a product rule or anything like that. I just took the derivative of the top. I just took the derivative of the bottom. And this is not violating the quotient rule because we weren't trying to take the derivative of the original function. We're just using what L'Hopital's rule tells us to do. And now we can try and compute the limit like we did last semester. So we plug 1 in. When I plug in 1 now, I get 1 out. So that is my final answer. Let's do one more example in this video. So x is approaching infinity here. So I start out by plugging infinity in and I get infinity over infinity. This is indeed a case where I can use L'Hopital's rule. So it's good to go ahead and tell me when you're using L'Hopital's rule. So I still have a limit. I replace my numerator with its derivative, which is 1, and I replace my denominator with the derivative, which is e to the x. When I plug infinity in here, I'm going to get 1 over a very big number. 1 over a very big number gives us something very close to 0. So I get 0 out. Okay. So I will do the next examples in the next video, but you should try some of these on your own first. Okay, so let's keep going. So hopefully you've tried these. So in this one, I get 0 over 0 when I plug 0 in. So I can use L'Hopital's rule. When I use L'Hopital's rule here, the derivative of x is 1. To take the derivative of sine of 4x, I need the chain rule, and I get 4 cosine of 4x out. Now when I plug in 0, cosine of 0 is 1, so I just get 1/4 out. Okay. L'Hopital's rule is really nice. I like it. Sometimes it can get a little more complicated though. So we'll do some more interesting examples down here, I think. So, okay, so as x approaches infinity, natural log approaches infinity. The graph of natural log of x looks like this. It grows very slowly, but it does approach infinity. So we're going to get infinity. The cube root of infinity, still a really big number, so we still get infinity over infinity. So we can use L'Hopital's rule. If you got like 0 over infinity, you could not use L'Hopital's rule. If you got 5 over 6, you could not use L'Hopital's rule. Only if we get 0 over 0 or infinity over infinity. If you had like negative infinity over positive infinity, that's fine too, but it has to be an infinity and an infinity. Okay, so now we have to take the derivative. Derivative of ln of x is 1 over x. This is x to the 1/3, so its derivative is 1/3 x to the negative 2/3. Now I need to plug in infinity. This looks super messy, so I'm going to simplify things before I plug infinity in. So this will be the limit as x approaches infinity. So I've got like a fraction over a fraction here. This
we could write as 1 over 3x to the 2/3. That's all over 1 over x. So that's the same thing as 1 over x times 3x to the 2/3 over 1. Now I can subtract exponents. So I have x to the first and x to the 2/3. So I'm going to have 3x to the 1/3 here. I'll just algebra there. Now when I plug in infinity, I get 3 over a very big number, which will give us 0 again. Okay, and one last example here. So this is a right-hand limit for approaching from the right, but we can still try plugging 4 in first. So when I plug 4 in, I get 10 over 0. Notice that's not 0 over 0. So this is not L'Hopital's rule. And I cannot emphasize that too much. Do not use L'Hopital's rule when you can't use it. Okay, so we need to deal with this with methods from last semester. And I'll just do this quickly. If you don't remember this too much, that's okay. So in this case, I got a number over 0. So remember from last semester, that tells us our answer will be some kind of infinity or does not exist. We're working with a right-hand limit here. So if I plug in a number a little bit bigger than 4, I'm essentially going to get 10 in the numerator, and I'm going to get a small positive number in the denominator. 10 divided by a small positive number gives us a positive infinity. So that would be our answer there without using L'Hopital's rule.